Hi, this is Rohan from educator.ai. Let's dive in. Before a language model can do anything clever with your text, that text has to become numbers. In this video, we'll build a precise mental model of the very first step in that pipeline, tokenization. It's small, it's mechanical, and getting it wrong quietly breaks things downstream. Here's the core issue. A large language model, an LLM, is at heart a giant function that multiplies numbers together. It has no notion of the letter A or the word cat. So the moment you type text, there has to be a translation layer that turns those characters into integers. That layer is the tokenizer. This isn't academic. When you call an API, you pay per token, not per word. The context window, the maximum amount of text a model can hold, is measured in tokens. And when a prompt behaves strangely, the cause is often that your text got chopped in a way you didn't expect. So it pays to see how the chopping works. Think of a fixed box of Lego bricks. The tokenizer's vocabulary is that box, a set list of pieces decided ahead of time. To represent any text, it snaps together bricks from the box. Common words get their own big single brick. Rare words don't have a brick, so they are assembled from several smaller ones. Let's name the pieces. The vocabulary is a fixed list, often around 100,000 entries. Each entry maps to exactly one integer, its token idv. Crucially, entries aren't whole words, they're subwords, fragments like tokenization, or even single characters. This lets the tokenizer represent absolutely any text using only its fixed box. Start simple. The phrase, "the cat sat," becomes 3 tokens, 1 per word, because each of these words is common enough to have earned its own brick in the vocabulary. Notice each token is just a lookup into an integer id. This is the happy case, where tokens line up neatly with words. Look closer at those tokens. The space before cat isn't dropped. It's baked into the token itself, shown here as a dot. To the tokenizer, cat with a leading space and cat without one are 2 different bricks with different IDs. This matters more than you'd think, and we'll see it bite in a moment. Now a longer word, tokenization. There's no single brick for the whole thing, so the tokenizer assembles it from pieces it does have. Token plus ization. 1 word, 2 tokens. This is the subword idea in action. The model never sees the word as a unit, it sees these fragments. Push it further with gibberish like G, X, Q, Z, P, T, L. Now there are almost no useful bricks, so it shatters into single letters and tiny fragments. This is why rare names, code, or unusual strings quietly eat up far more tokens than plain English. Familiarity is cheap, novelty is expensive. Here's the same word in 2 guises. Capital T token and lowercase token with a leading space are entirely different tokens with different IDs. The tokenizer does no lowercasing for you. Case and whitespace are part of the signal, so a stray capital letter or an extra space genuinely changes what the model receives. Zoom out and the full picture is a short pipeline. Your text goes in, encode splits it into subwords and looks up each id, and out comes a plain list of integers. That list is all the model ever sees. And it's reversible. Decode takes IDs back to text. Let's confirm these exact numbers with real code. Here it is for real, using tick token with the CL100K encoding. We encode tokenization, then capital, token, then token, with a leading space. Watch the output. Tokenization comes back as 2 IDs, and the 2 casings of token give different single IDs. Nothing is memorized here. These numbers fall straight out of the fixed vocabulary. One more, to hammer home the difference. A single long word counts as 1 word by splitting on spaces, but the tokenizer chops it into many subword tokens. Token count and word count are simply not the same thing. When you budget for a context window or an API bill, tokens are the number that matters. So let's clear up the traps. A token is not a word. Long words split and some short strings fuse. Spaces and capitalization are not stripped away. They change the IDs. And the popular rule of thumb, characters divided by 4, is only a rough estimate, not a guarantee. Trust the tokenizer, not your gut. Here's the review lens. On the left, the safe habits. Count tokens with the actual encoder for your model, preserve whitespace as written, and expect rare words to fragment. On the right, the ways people get burnt. estimating limits by words, reusing the wrong encoder, or mangling spaces. Small carelessness here shows up as truncated prompts and surprise builds. To wrap up, the model only ever sees integer tokenides, produced by a fixed subword vocabulary. Common words are a single token, rare ones fragment into several, and both spacing and casing change the ides you get. Keep this mental model close, because every next step, embeddings, attention, generation, begins with these tokens.